So till now we have discussed the introduction of vector and a lot of things we have learned. Now starting components of vector. Components of or splitting of vector. Clear?
Yes, sir.
So splitting of vector means what? For example, this is x and y. If I draw x and y like this, and this is any vector that is projecting from or originating from point O, like this. Clear? Let us suppose this vector is OA. I am taking A vector. So when this vector is moving like this, and then its projection on x-axis will be moving like this. Okay. Then already I told you like how to find the projection. Just drop a perpendicular. For example, if you want projection on x-axis, then draw the perpendicular on x-axis like this. Then this is the projection on x-axis. Clear? This is the value. If this is theta, then how much this? A cos theta. Clear? Now, when this our original vector, it is moving like this. Clear? Then its projection, one of the projection is moving like this. You just imagine when your car is moving like this in this direction, then its projection, that shadow of the car is moving like this. Okay, one shadow on x-axis will be moving like this because car is also moving. So this
Yes,
is
sir.
the projection on x-axis, and this is the magnitude of projection. Now, in which direction this is moving? I will given by the direction along x-axis. Clear? Similarly, projection on y-axis. On y-axis, projection will be this is the projection. Just drop a perpendicular on y-axis. Then this is the projection on y-axis. So when this original vector is moving in this direction, then their projection are moving in x and y direction. One projection is moving in the y direction, one is moving in the x direction. Clear? So this is a cos theta, then this is what? This is a sin theta. A sin theta. And if this is a sin theta, then this is also a sin theta. A sin theta. Clear? Now, if I ask you like this projection, how to write this? Like these are vector, na? Because they have magnitude and direction. Now, I want to write, for example, this is B, this is C. So OB vector I want to write. I know that its magnitude is A cos theta and it is moving along x-axis. There, it is moving this magnitude, this whatever I have written A cos theta. When this OA is moving like this, then this A cos theta is moving along x-axis. If you don't know the direction, then we are taking the help of unit vector. So along x-axis, our unit vector is I cap. So I will take the help of, because direction of this and the unit vector along x-axis is same. Then unit vector will help us to indicating the direction of vector. Here, so A cos theta I cap. Similarly, OC vector will be A sin theta J cap. Already I have told like the unit vector denote the direction, or it is specify the direction of an unknown vector. Clear? So OB, OC you got. Now can you see like this is our triangle. One triangle is going to form OBA like this. Sense of rotation like this. This OC vector is equal to BA vector, we can say. And here, if you look at carefully, OB vector will be like this. BA vector will be like this. If I draw, this is BA vector, this is OB vector. Okay. And this OA, just join. If you look at which I have drawn, I can write like this. This is triangle. This is A vector. This is A sine theta. And this is theta. Like this. This is A cos theta. Okay. Now, if you look at carefully, if you apply the triangle law of vector addition, like tail to head, then tail to head. Sense of rotation, you are moving anti-clockwise manner. O to B, then B to A, then again A to O. So we can write OB vector tail to head plus BA vector plus AO vector is equal to 0 because you are starting from O, then again come back to O. Then the net displacement is 0. That's why I have written 0 vector. 0 vector is displacement. Clear? Now OB vector, how to write OB vector? A cos theta. Direction is I cap. BA vector, A sin theta. Direction is J cap. Then AO vector. AO vector I need. But what is given? OA vector. OA vector is A vector. I need AO means you will take the negative of this minus A. Clear? Tail to head, tail to head. If you want, for example, this is given OA vector. You want AO vector. Then multiply this vector with minus sign. Then it will rotate like this. Clear? Then this vector is minus A, which is what? Minus A is what? Clear? So you can write here minus A vector equal to 0 vector. Any doubt up to this point? Please write. So A vector can be written as, can I move? Have you written? Your voice is not coming.
Sorry, sir, I was on mute. No, sir, I am going to complete.
Okay, you have written?
No, sir.
Okay, please write. Okay, you have written. So this A vector can be written as A cos theta. 1 minute. This A vector, if I write here, A vector can be written as A cos theta I cap plus A sin theta J cap. Okay.
Yes, sir.
Now here A vector is given as like A cos theta I cap plus A sin theta J cap. So what I have written, if you look at carefully, what is our, in this what I have drawn, this A vector, it's one of the projection. This is A cos theta I cap. Clear? And this is one of the projection. This is what? What? A sin theta.
J cap.
So what is this? If you look at carefully, in many of the books, they have written like A vector is equal to AX I cap plus AY Z cap. And they have mentioned like this AX is what? AX is horizontal component. Clear? AX is what? Horizontal component. horizontal component of given vector. Clear? Of given vector. Given vector is a vector. Or we say this is what? One more name. It's a projection of a vector on x-axis. Clear?
Yes, sir.
Similarly, like ay is what? Sorry, I should not write like this. Okay, simple ay. This ay is what? Vertical component of given vector. Clear? Or we say one more name.
Projection
Projection of
A vector on y-axis.
very projection of a vector on y-axis. Clear? So this angle theta is
Yes, sir.
made from like this anti-clockwise man, like this. Okay. So any
Yes, sir.
vector can be written. So this is parent vector. Okay. This is parent, and this is a child vector. You can say these are the child. Just for understanding.
Yes, sir.
So child. If you add, you will get a parent. So any vector can be written as a linear combination of two vector. Any vector can be written as a linear combination of its components. Component vector. So you can write here. Note linear means like you are adding addition. By addition, you are adding two vectors. So you can write any vector can be written as a linear combination of its component vector. Clear? One more meaning is that if you know the
Yes, sir.
components, for example, what happened? 1 minute. Slide finish. Let me add some slides. Okay. So what I have speaking like any vector can be written as a linear combination of its component vector. Meaning is that very important. Like if you know the component vector, for example, like this is vector, this is vector. Okay, if you know these two vector, a cos theta, a sin theta, like this. If somebody is asking like draw the resultant vector, then resultant will be like this only. This is a resultant. It will be what? Resultant vector, that is A vector, is a combination of its component vector. So I can write component is A cos theta, direction I cap, A sin theta, Z cap. Clear?
Yes, sir.
Any doubt? Till now, any doubt?
Not out, sir.
Okay. So you should
First,
understand like how to take the components. Any question like you will find, and it's a very, very important topic. You ask me like even entire mechanics, like components of vector, it will always behind you. Like every time they will ask, find the net force, find the components of vector, find the fx, so that system is in equilibrium. Clear? So every time they will ask many question, and you need to use this. You should be familiar. For example, if I ask like vector is given like this, okay, this is a vector. Now you please tell me if angle is given like this is 30 degree, and this vector is having the magnitude 4 Newton. Then I will ask you like find its horizontal component, vertical component. For this vector OA here, which I have asked, that is 4 Newton. Its magnitude is 4 Newton. I want to know what is the horizontal component. Means I'm asking simply AX, AY. AX vector,
2 root
AY
3,
vector.
sir. Ax vector is 2 root 3.
Wrong. One component will be like this now. One component will be like this. This is X. I have taken, this is Y. Okay. So as per this X or Y common which I have taken, you please tell me if if I have already explained like this is X, this is Y. Clear? And what I have asked like our vector is like this. Okay. And it is making an angle 30 degree. 4 Newton. Clear? So see, it's one of the component will be like this. This is the one of the component. One component will be like this. Then you please tell me this component is along negative x-axis now.
Minus root 3,
Yes, you
sir.
should tell me like
Minus 2 root 3.
yes. If I ask AX will be here, AX vector will be very good 4 cos 30. In which direction it is? Minus I.
Minus
Similarly,
I.
AY, its vertical component will be 4 sin 30. In which direction? Z cap.
J.
And this is no like 4 cos 30 is root 3 by 2. And it is 2 root 3. 2 root 3 minus I cap.
This
This
one
is sin 30 half.
2 J cap.
2 Z
2
cap.
J cap.
Any doubt?
Not out, sir.
If I ask like this is the, in this case, what is the horizontal and vertical component? X or Y this. This is XY, X axis, this is Y axis. And vector is given like this. This is 4 Newton. And angle is given like this. 30 degree. Now tell me.
And 2 root 3 minus I cap, and the vertical component is 2 minus J cap.
Yes, very good. I'm really impressed. Very nice. So one component will be like this. Very good. And one component will be like this. Very nice. So AX will be like simple 2 root 3 minus I cap. AY vector means
2
2
minus J cap.
minus J.
Minus
Okay. Now tell me if it is like that. Vector is like this. 4 Newton like this. This is y and x. What is the x or y component? Tell me.
AX will be 2 root 3 I cap. Sorry, no, that's not the.
Hmm. Tell me.
1 minute, sir. I think I forgot the value for that.
Simple, na? See, this vector is like
Zero.
this, like
AX
this.
will be 0,
It is making 90 degree, na?
sir.
Will you see? You just in a
Sorry, horizontal.
simple. You understand?
Cos,
Very nice. Very,
mm,
let me complete. 490. This is at 90 degree. Okay. When you are at like you are moving like this. Will you see shadow on x-axis? If you are going 90 degree, then will you see shadow on x-axis? No. If there is no shadow on x-axis, there is no component on x-axis. Or you can say it will be what? Ax vector is zero vector. Simple. Clear. There is no horizontal component. Clear. Only vertical
yes, sir.
component will be what?
Vertical component 4 I
Entire
cap.
4 Newton will be in z direction.
Vertical component.
Clear. If it is like that,
Yes, sir.
then on x-axis, if you draw perpendicular from this line, then there is no shadow. There is no length of shadow. There is no horizontal component. But if you provide shadow, if you take the shadow of this on y-axis, perpendicular, take the perpendicular from here to on y-axis, this entire length will be the shadow. Clear? That's why I have written Ay will be 4j cap. But if I ask like this, for example, this is our vector 4 Newton, and this is x, and this is y. Okay. Now tell me horizontal component, vertical component. This is 90. Okay. Now here like our vector is like this, 4 Newton along x-axis. Tell me.
Sir, it will be 0 for x-axis, sir.
Mhm. If vector is lying on x-axis like this is like this, then if you take a shadow of this on y-axis, there will you see shadow?
No, sir.
Then there is no component on y-axis. On
That's what, sir. It will
x-axis
be 0.
entire. So y-axis there is no shadow till this question. Ay will be 0, nothing, no shadow, nothing, no value. Similarly, ax will be here 4 I cap.
Sir, can
You
you please
just
explain the difference between this question and the previous question, sir?
sure. My question is that if a vector is like this, okay, in terms of understanding, I'm telling this is 4 Newton, okay. It is making an angle how much? 90 degree. If I ask you what is the shadow of this vector, for example, this vector is going like this, okay, then shadow of this vector on y-axis will be like this now.
4 cos 90.
This is the shadow now. Shadow means if you are providing light from this end, light, then
There
shadow on
won't be
this.
any horizontal component.
Yes, yes, very good. If you provide a light from here, then there is no shadow. There is no shadows. Point like there is no shadow you will see on x-axis. That's why I have written directly shadow on x-axis 0. That's why directly I have written Ay will be 4z.
0.
Clear?
Oh,
Vertical component.
yeah.
Clear? Horizontal component is 0. Again, I will
Yes,
explain
sir.
this. Meaning is that if you see like this is a vector, 4 Newton. Then on x-axis shadow will be, this is the shadow, na? On x-axis. Clear? Then on x-axis, this is a projection. This is the horizontal component. But on y-axis, if you you never see shadow because it is parallel to x-axis. Clear? That's why I have written ax means horizontal component.
So
Vector.
this point only I don't understand.
I'm telling. See, if a vector is like this, okay, O A. If it is making an angle theta, then how to find the shadow? From A, drop a perpendicular. If you want on x-axis, drop a perpendicular. This is the shadow. Clear? Similarly, on y-axis, drop a perpendicular from this point. This is the shadow on y-axis. Clear? This is ax.
Yes, sir.
This is ay. Okay? Clear? Is it clear to you?
Sir, I think you're on.
Hello?
Sir,
I have written ax
yeah,
vector
yes,
and ay
sir. Now it's
vector.
clear.
Clear?
Yes, sir. Clear.
Now I will explain. You please tell me if I increase this
Yes, sir.
theta. If I increase this theta, for example, 0 to, if this vector theta is 0, then this OA vector will be like this. Okay? Clear? If this theta is 0, then this vector will
Yes,
be
sir.
like this, OA vector. It is like this, na? It initially like this. If theta is 0, then it will be like this. If theta is 90, then this vector will be like this. Clear? If
Yes,
theta
sir.
is 0, this OA vector will be like this. Clear? Then this vector is exactly
Yes.
equivalent to its projection. If it is completely lying on the x-axis, then this entire length you will observe on x-axis. Clear? If it is lying parallel to x-axis, if this vector is lying parallel to x-axis, this entire length will lie on x-axis. Clear? If I say, if this vector, if I say simply, you just tell me, if this is the vector, A vector, this is making an angle theta. I want to know projection on x-axis, then you drop a perpendicular.
Yes, sir.
If this theta is, for example, 60 degree, and the length of this vector is 4 Newton. This length is 4 Newton. Clear? Now its projection on x-axis, you just drop a perpendicular like this. Then how much this length? OE. OE is what? 4 cos 60. Clear? OE is what? 4 cos 60. This is the projection. But if I ask like projection vector like
Yes,
OE
sir.
vector, it is 4 cos 60 I cap. Clear? Okay. What I'm saying,
Yes.
this vector OA vector is like this. Okay, it is 4 Newton. It is making an angle theta 60 degree. Then its projection on x-axis will be OE. Clear?
Yes, sir.
Now you please tell me, this OE length is how much? 4 cos 60 means 2 Newton.
Two I cap.
Means 2 I cap.
Sir.
2 I cap. Actually, this is AX vector. horizontal component. Clear? Horizontal component vector. Similarly, on y-axis,
Yes, sir.
this is the vertical component. How much this? 4 cos
Um,
60, 4 sin 60. 2 root 3.
yes, sir.
So this, if I take this m, so OM vector will be what? Vertical component. This will be 2 root 3
2
j
root 3
cap.
theta.
Clear? Now try to understand the length of this vector when theta is 60 degree. When theta is 60 degree, then our given vector is 4 Newton. I am writing its child vector. Ax, Ay. Only magnitude, okay? How much? On axis 2, 2 root 3. See, this length is big. This length is big, but the projection, that is shadow. Shadow on x-axis is less than the given vector. Our given vector is 4 Newton. Clear? Our given vector is 4 Newton, but its shadow. Shadow, that is Ax and Ay, that is horizontal component, and vertical component is 2 and 2 root 3, which
Yes,
is
sir.
less than the given vector. Now you please tell me when theta is what? If I change the theta to 0 degree, not 0, just understand 30 degree. Then tell me what is the value 4. Ax will be what? If theta is 30 degree, then Ax will be
4 cos 4 cos 30
4
degree.
cos 30 means 4 root 3. Root 3 by 2, that is 2 root 3. Ax will be 2 root 3. Ay will be 2. Sin 30. Similarly, if I change the theta, same vector I'm explaining like how this shadow is going to increase or decrease. And when the shadow is exactly equivalent to its given vector, you please tell me when theta is 90 degree. When theta is 90 degree, then what is the Ax value? Tell me.
0, sir.
Ax value is 0. Ay?
0, sir.
Ay?
4. 4.
4. Did you see what I have explained? When theta is 90 degree, then the projection is equivalent, exactly equal to what? The given vector length. And this is the maximum length you will observe on y-axis when theta is 90 degree. Clear? So here this is, if this vector is 4 Newton, then its projection on y-axis will be 4 Newton. Clear?
Yes, sir.
Understood? But there is no
Yes, sir.
length, there is no projection, there is no length you will observe on x-axis. That's why I have written 0 degree in the previous case. But if theta is like 0 degree, 0 degree, then its projection will be, tell me.
4 Newton in Ax and 4 Newton in Ax and 0 in Ay.
So here like the vector will be like this now, projection, this is projection. Now if I draw the projection, so there is no projection on y-axis, projection on x-axis will be like this only. Here projection will be like this. Here projection will be on y-axis, x-axis. If I draw equivalent like this, it will be like this. If I draw for both, here similarly projection will be like this. Okay,
Yes, sir.
these are the projection which I have drawn. So you have seen like when theta is 60, 90, 60, 30, 45, any angle in between 0 and 90, then the projection you will see on x-axis and y-axis. Clear? But when theta is 90 degree, then there is
Yes.
no shadow on x-axis. Clear? Entire length you will observe on y-axis. Similarly, when theta is 0 degree, then this vector is parallel to the given vector is parallel to the x-axis. The entire length will lie on the x-axis. So projection on y-axis is 0, but projection on x-axis is not 0. That is 4 Newton. I never explain this in this way to anyone. Believe me. First time using this technique. Okay, understood?
Yes,
Projection
sir.
clear?
Understood, sir.
Projection clear. Now why it is I have
Yes,
written
sir.
like this
Clear.
in the previous case. Projection simply means the
Yes, sir.
shadow. In class
Yes.
6, 5, 4, 5, like
Sorry.
you have understand like how to find the shadow. If you take any object, shadow means like one. Actually, slide finish. I need to add some more slides. What I'm explaining. Shadow, I think clear. Shadow, that's why I'm saying learn like a shadow. See shadow. If shadow is 0, then projection is 0. If there is shadow will be maximum length when theta is 0 and
Yes,
90.
sir.
Clear? Okay. Now, if I explain like this, one more way, you please look at here. This is a circle. This is the circle. And this is center.
Yes, sir.
You will tell me, you will draw the projection. This is my vector. Okay. This angle is 60 degree. When theta is 60 degree, then projection will be on x-axis and y-axis. Draw. Draw the projection on x-axis and y-axis. So on x-axis, drop a perpendicular. This is the projection on x-axis. And projection on y-axis, drop a perpendicular from the given vector on y-axis. This is the projection on y-axis. Clear? X and y.
Yes.
But if I ask like, if my vector is like this, when theta is different angle, for example, 30 degree. Here angle, I will write angle is theta is 30 degree like this. Because I have no space, so I'm writing like this. Now you please tell me when theta is 30 degree, draw the projection on x-axis. Then projection on x-axis will be like this. Okay. Then projection on y-axis will be like this. Then in which case length is more? X on x or y? When theta is 30 degree on. Now see the important concept here. When theta is 30 degree. Clear? When theta is 30 degree, then you can see the projection on x-axis more.
Yes, sir.
Their length is more as compared to the projection on y-axis. Similarly, if a given vector is making
Why
an
not?
angle, for example, less than 30 degree, they are making an angle like, for example, 0 degree. Okay. Here theta is 0 degree. When theta is 0 degree, then projection on x-axis will be complete length. Because if you drop a perpendicular on x-axis, it will be complete length. But there is no projection you will see on y-axis. Okay. Similarly, if you are increasing the theta, for example, more than 60 degree, like this. Okay. It is more than 60 degree. Let us suppose here angle is
Yes, sir.
70 degree. So when angle you are increasing, then what is our observation? Observation is that if you drop a projection on x-axis like this, it will be like this. Okay. Similarly,
Yes, sir.
projection on y-axis will be like this. So when you are decreasing, when you are increasing the angle, concept is what? When you are
Projection
increasing
is more on
theta,
y-axis.
projection on y-axis is going to increase. Projection on y-axis is going to increase. When you are decreasing theta, then projection
Projection
on
on x-axis.
x-axis is going to decrease. You can check. Now, if you can check like if theta is like that, if theta is the given vector is like this, Okay. If they
Yes,
have
sir.
given an angle like this, okay, then no need to worry. They have given an obtuse angle, find this angle, smallest one. Because anyway, we need a projection. If vector is like this, then how to find the projection? Simply from this vector, drop a perpendicular on the x-axis. This is the projection on x-axis.
Excuse me, sir.
Yes, yes.
Sir, but if theta decreases, projection on x-axis will increase, right, sir?
You can check here also, like same thing you will observe.
No, sir. In that note, you wrote that theta will decrease if x-axis.
If
Theta
theta
when theta
decrease,
decreases,
I mean to say that if you are moving like, what are you saying?
if theta decreases, projection on x-axis will increase, right, sir?
Yes, yes, increase. Clear? If this is a observation we have found, like where you have found like in 0 to 90 degree, okay, 0 to 90 degree, I have observed like this is my observation, 0 to 90 degree. Clear? Now see here,
Yes, sir.
see very carefully. So this angle we have found, like projection on x-axis will be like this. Clear? Now on y-axis projection will be like this. This is a projection on y-axis. But if the given vector is like this, okay, then for this vector, projection on x and y will be like this. On y-axis it will be drop a perpendicular on y-axis, drop a perpendicular on x-axis, projection on x-axis will be like this, projection on y-axis will be like this, total length. Okay. And if you make
Yes,
this like theta, if you are making this like theta is 180 degree, you are making this like this. Given vector is like this. Okay. Given vector is like this. Then you will observe like there is no projection on y-axis. The projection when vector is lying parallel to x-axis, then projection will be like this on x-axis. Clear? But there is no projection on y-axis. So you can check like when you are moving from 0 to 180 degree. When you are moving from 0 to 180 degree, then first projection is moving like this. Projection length, what you are doing? You are increasing the
yes,
theta
sir.
like 0 to 90 degree. In case if you say 0 to 90 degree, the projection length, you can check when theta is 0. Projection length on x-axis is more. When you are increasing the theta, the projection length on x-axis is going to decrease. Then if you are going more than 90 degree, then not only then projection length on x-axis is going to increase. Okay, you can check. Initially projection length is this when theta is 0. After this you are increasing the length, the projection length will be like this. Okay, it is going to shorter. When theta is 90 degree projection, there is no projection on x-axis. Clear? When you are going more than 90, then projection direction will reverse. It is going to increase. Clear? On x-axis. Clear? Is it okay? Any doubt? Clear? So on y-axis, if you look at when theta is 0, then there is no projection. When you are increasing the theta, clear? This is our C center. Clear? When theta is theta is 0, then this is a projection on x-axis. When theta you are going to increase, projection length on x-axis is going to decrease. Clear? But if you are going more than 90, then projection length on
Yes, sir.
x-axis is going to increase. Clear? So 0 to 90 degree, you have observed this? Clear? Now when the theta is 0 degree, then there is no projection on y-axis. When theta you are going to increase, projection length on y-axis is going to increase. Initially like this projection, then after this length is going to increase. Okay?
Sir,
Like
when
this.
theta is 90, no projection on x-axis, right?
Yes. There is no projection on x-axis. And after 90, it will reverse the direction. Okay? It will reverse its direction.
Yes, sir.
Clear? And now if I ask like this is up to this, clear?
Yes, sir.
But if I ask you, same thing. This is my center. Now if I ask you like this, given vector is like this. Okay? Now, if this is the theta, if you are, this is theta. Okay? Theta is this. Now, projection on x-axis will be like this now. Clear? On y-axis, it will be like this. Okay? If you again increase the theta, vector is like this. Then projection on x-axis will be decrease. On y-axis, it increase. Okay? Just you understand increase or decrease concept. Projection will be more clear to you. When you increase the theta again, like this is our given vector.
Yes, sir.
Then on y-axis projection length little
Projection
bit
on
increase
x-axis.
then on y-axis it will decrease. And when this given vector is exactly like this is our given vector, then in this case you will see there is no projection
Full
on
projection
x-axis,
on y-axis.
but on y-axis projection will be like this. Clear? If you are going more than that,
Yes, sir.
if you are going more than that, for example, your vector is like this. Okay, here theta will be like this. Okay, from x-axis. Now here projection length, just tell me. Projection length will be like this on x-axis. Drop a perpendicular on x-axis. This is the projection length. On y-axis, drop a perpendicular. This is the projection length. Clear? Is it okay?
Yes, sir.
When the vector is like this, angle again increase. Okay.
Yes, sir.
Then here projection on x-axis will be like this. Projection on y-axis is going to decrease. While projection on, when you make like this, when theta is 2 pi, when vector is like this, 2 pi, then in this case, the projection on x-axis is complete vector on x-axis. Then there is no projection on x-axis. Now see the observation in the back. First, see here. When theta, see here. When theta is more than 180, when theta is more than 180 and less than 270, then see the projection on x-axis. X-axis projection. Its length initially more, and finally its length is going to decrease. Clear? Understood?
Yes,
on x-axis. After more than 270, when theta is more than 270 and less than 360, then the projection length is going like this. You can see projection length is going to increase. Okay. Clear?
Yes, sir.
I'm writing direction of projection. See, direction of projection, how the projection is moving. Here, when theta is more than 180 and less than 270, the direction, this length is going to decrease. So I'm drawing the direction, okay? This direction of, in this direction, length is going to decrease. Clear? Understood?
Yes, sir. Understood.
Okay, one. When theta is more than 270 and less than 360, then this is the direction in which projection length is going to increase. Like this. Initially length is this, then length is going to increase. Okay. Again, when in the previous case, if you look at here, in this case, theta is greater than 0, less than
Less
90.
than
Then in
90
this
degrees.
case, you can check when theta is 0 degree, projection length is more. Then when you are increasing the theta, this length is going to decrease. Finally, it becomes 0 when theta is 90. Okay. Then I am drawing the direction of decreasing length or simply projection, direction of projection. On x-axis, okay, I'm not, same thing, same pattern you will see on reverse pattern, you will see on y-axis. If it is increasing on x-axis, this is decreasing on y-axis. Clear? Now here,
Yes,
like
sir.
if it is more than, here like what is the angle? Greater than 90 and less than 180 degree. You can write, if it is like, I have taken here less than 90, you can less than 180, or in the next case, I have started from 180. 270 case I have taken now. Okay. Here you can. Anyways, you need to take all the values. Clear? My concept is if it is more than 90, 90 I have taken here. Okay. So second case, just see very, very carefully. If we are going from more than 90, less than equal to 180 degree. Then when it is 90, there is no projection on x-axis. Then projection is going to increase like this. Okay. This length is going to increase. Initially no length,
Yes, sir.
then like this. Okay, length is going to increase. So projection length on x-axis is going to increase. So did you observe that? First, projection length is more like this. When you are increasing the theta, this projection length is going to decrease on x-axis. Decrease, finally 0. When you are increasing theta more than 90, less than equal to 180 degree, then projection length is going to increase but in reverse direction. Clear up to this? Clear? When it is
Yes, sir.
more than 180 degree and less than 270 degree, then this projection length is going to decrease like this. Okay, you can check. Next slide. You can check. It is going to decrease. When it is more than 270 degree and less than 360 degree, this projection length is going to increase but in reverse direction. Okay. So did you see like it is oscillating? It is going left like this. First length reduce 0. Then again going to length is going to increase but in reverse direction. Again length is going to shorten. Then again length is going to increase. Clear? So
Yes.
in the next, there is a chapter in like 11th class as system, simple harmonic motion that you will learn later. But I'm telling like this concept of projection is clear. Projection is clear. Projection means length,
Yes.
shadow length. Shadow length is always less than the given vector length. Okay. But it is
Yes,
exactly
sir.
equivalent to the vector length only when theta is 0 and 180 degree, 270 degree and 360 degree. Clear? Now, if
Yes,
I
sir.
ask you like one question is that if theta is 0 degree, vector is like this. This is 4 Newton. Clear? If you increase the theta by 180 degree, then how will you draw this vector? It will be like this. Okay. This is 4 Newton. If it is 270 degree, how you will draw like this? 4 Newton like this. 270 degree. If it is more than 270, like 360 degree, vector will be like this. When it is 90 degree, vector will be like this. Because vector is exactly equal to shadow. Okay. So this vector is going to rotate. Maximum length you will observe here only. Clear? At what angle? When theta is 0 degree, theta is 90 degree, then you will see complete vector. Theta is 270 degree. Okay. Again 360. But in between that, you will observe the length. I'm not taking 090. In between length, you will see the projection is going to oscillate. If it is more on x-axis, then it is less on y-axis. Clear like this. If you decrease the projection length on x-axis, then projection length is going to increase on y-axis. If you decrease on y-axis, it is going to increase on x-axis. You can check. Clear?
Yes, sir.
If you take larger projection on x-axis, then smaller length of projection on y-axis. If you decrease the length of projection on x-axis, there is increase in length of projection on y-axis. Clear? Okay. So if you decrease like in along one direction, it will increase in another direction. Okay.
Yes, sir. No doubt, sir.
Projection topic is clear or not?
Very clear, sir.
Very clear. Okay. Now this 1 minute. If anyone is asking like any question, like if they are asking, they have given an angle like this. This is the vector, for example, 4 Newton, and they have given an angle like this, 120. Then always like if it is 120, total angle is pi, 180 degree. This angle is what? 60 degree. Always take a smaller angle like this. Then projection will be like this. One projection on x-axis y-axis will be like this. Clear?
Yes, sir.
So it will be 4 cos 60. And it is what on y-axis? 4 sine.
Side 60.
So it is what? 2 root 3.
4 into 2, 4 into root 3 by 3.
Similarly, if I draw the vector like this, 4 Newton like this. Okay, this is 4 Newton. And they have given an angle like this. This is like, for example, how will I take? 230. This is 230. Okay. Then if it is 230, total angle is 270, then this will be how much? 270 minus 230, 40.
40 degrees.
Then take the component like this with respect. Clear? Then if it is you have taken 40 degree, no problem. 40. This is 4 Newton, na? Then on y-axis it will be 4 cos 40.
4 cos 40.
On x-axis 4 sin
40.
Okay, the direction, for example, if I take theta with whatever axis it is, y or x, then there is cos only. Meaning is that if I say like this is one vector, 4 Newton, if I take theta from here, 60 degree, then it is sure it is cos only, 4 cos 60 on x-axis projection. On y-axis, it will be 4 sin 60. Any angle is given. For example, they have given an angle like, if vector is like this, and they have given an angle like this, 330. Then take this angle. Take this angle, how much? This is 4 Newton. Total angle is 360. 360 minus 30. How much?
30,
60? 30 degree.
30
Then if they are
degrees.
asking projection on x or y, then very easy, drop a perpendicular. This is the
4
projection on
cos 30,
x-axis. Projection
4
on
cos 30,
y-axis.
4 sin 30.
Very good. 4 cos 60, cos 30 is 2 root 3. Direction is where? Along y-axis, I cap. Okay. Similarly, here projection
2
will
j cap.
be
2
along,
j cap.
not 2j cap,
Sorry,
2
2
minus
minus
j.
j cap. 2
If I take
minus
plus
j cap.
x-axis plus y-axis, like this, then you should say like this. If I asking like in terms of vector, so on x-axis it will be 2 root 3 I cap. On y-axis it will be 4 sin 30, that is 2 minus j.
2 minus
Like this.
j.
Clear? Projection vector is clear, like this concept, components of vector.
Yes, it's clear.
Okay. Actually, overview is very important, and believe me, if you learn in such depth, if you learn any concept, learn in depth. That is my only opinion. Try to solve as many as problem. Projection concept should be clear. They can ask any question like projection. You should solve.
Yes, sir.
So I will stop the lecture. Clear?
Yes, sir.
Tomorrow I will take your class and I will discuss what I will discuss. I will discuss some. I think question. Are you facing any difficulty in numerical? This chapter.
So
See,
I was having my
huh? Basics of vector is over. Two things are left. One is sine law, volume of parallelepiped, and I think one topic is uh, like how to find like direction, cosine, direction ratios. Two, three things are left. Clear? No need to worry. Tomorrow I will discuss. Then we will finish this vector. After finishing the vector, we will start our mechanics like forces, then friction, clear momentum problem, relative velocity, then umbrella concept like man is moving and rain is coming, relative velocity concept like, and problem is like that a man is swimming in a river. He's going to cross a bank, river, sorry. Then such problems like, so this introduction to force and like vector we will finish tomorrow. Clear? Now we will start, not now, later on, we will start forces. Clear?
yes,
So in forces, like I will provide you TPP, everything. Clear? This is basics only.
yes,
I think no need of requirement of that, because you will find several application of this vector concept which you have learned now in that. Okay. Second thing, like integration differentiation, like your teacher taught you, like.
no, sir. I mean, I joined in the middle of that thing, so I couldn't.
Okay, so you do one thing today only. Till now, this topic is going to read a little bit differentiation, integration, basics only. Basics only. No need to go in depth. Clear? Because I'm not. I will use. But I will use. I will not give such problems again. Okay, I will. I am going to start. Otherwise, I will. But if I start, then it is taking lot of time. Clear? Differentiation, integration. Don't worry. I will start.
Today evening, I'll go through it again.
You try, because there is no big math is required. Basics, like what is the meaning of integration, what are the
Yes, sir.
formulas, at least this that much basics you should have clarity. Clear? Because when I'm going to start that time also I will explain, no need to worry, but I want like you should have clarity before that. Okay. Okay, Balamika, your I think network issue. Hello. Okay, some network issue I think at your end.
Sir, can you hear
Ah,
me, sir? I was having network issue.
I understand, no worry. You understand concept now, components of vector.
Yes, sir.
Okay, okay. So I will sign off today. Okay, tomorrow Diwali na. So in morning I will
No,
take your
sir. Right.
class.
Yes, sir.
Tomorrow there is no Diwali in South. Hello.
Yes, sir, but it's fine.
Okay, no problem for you. Na, I will take your class. Okay,
Sir,
okay.
can you hear me?
Yes, yes.
Yes, sir. Sir.
Okay, I think network issue at your end.
Yes, sir.
We will discuss in the next class. Okay. Take care. Bye bye. Good night. Good night. Not good night. Not good night. I'm not going to sleep. Actually,
After.
okay. Bye. Actually, here na weather is just like it is cold na. So too much.
Uh,
Yeah.